Anatomy is the science that studies the shape and structure of the human body and is the common thread running through the training and professional development of every doctor. The level of realism and accuracy of the representation of the body plays a crucial role in ensuring both effective dissemination of anatomical knowledge and high professional standards when practicing the medical profession.
During my medical studies, thanks to my professor Ferdinando, I became passionate about anatomy. This led me to want to explore some of the issues that this science was experiencing. In particular, I focused on lack of tools to access essential information, such as the actual light and colour of an anatomical specimen or the topographical relationships with the surrounding structures. I set myself the objective of finding a new way to make the definitive qualitative leap forward a faithful, ultra-realistic digital representation of anatomical specimen. In order to achieve the result, I combined 3 different technologies, including surface scanning, photography, and magnetic resonance. This way, I was able to produce an algorithm for image implementation, enabling an explorable 3-dimensional representation that was viewable from all angles, both on the surface and inside, and, above all, faithful in terms of light, colour, morphology, and anatomical topographical relationships.
The aesthetically beautiful is also didactically beautiful and therefore useful. The enthusiasm with which colleagues and students received our images encouraged us to continue with the project. Hence, we began to consider the opportunity to turn our images into 3-dimensional objects. We immediately thought about 3D printing, focusing on one crucial element for us: colour fidelity. This is why we turned to Mimaki's technology through Bompan.
At Bompan, since we were first approached by Giacomo and Ferdinando, we sensed the scope of the project and at the same time the challenges it posed to achieve the desired quality result. However, we embraced the challenge because we knew we had the right solution: Mimaki's 3D printing technology. Mimaki has transferred its extensive experience in developing 2D digital printers, as well as its know-how in colour and its patents, to 3D printing. The company's flagship product is the 3D-UJ553, the 3D printer that was used to develop and produce the first 3D printed organ with photorealistic quality, a heart. The quality of the source file is very high indeed, and only thanks to the properties of the Mimaki 3D-UJ553 printer, which is capable of replicating over 10 million colours, were we able to produce a product that was true to life. The very core of the project was to achieve excellent colour fidelity, and a 3D-UJ553 printer has made it possible to achieve this fundamental milestone in anatomical study.
This 3D printed heart results from an intuition, extensive research work, and the use of advanced technology. Through this combination, we've shown that we can make a difference.
I like to take inspiration from the Greek concept of kalokagathia. The aesthetic perfection of the body and the internal functional efficiency of the individual organs are closely linked. Health is beauty, and vice versa. A beautiful anatomical model is functional for learning, medical communication, and medical and surgical practice.